This gives you, number 14 gives you log of x plus log of 9 is greater than or equal to log of 5. Now, there's several different things that you can use to figure out that it wants you to graph this as the answer. What's the first way? There's a graph, right? And it says sketch the graph. All right, but if I take my calculator and start typing in log of x plus log of 9 is greater than or equal to 54, it's not going to let me do that. Okay, so I want to remind you how we're going to solve this. Okay, we're going to make a new document on our calculator that is a graph. No, I'm sorry. I'll tell you why later. Are you going to be nice today? No? Let me zoom in a little bit more, see if it'll be nice. Now are you going to be nice? Almost. Okay. What we need to put in our calculator is log of, log of x. Why didn't I put in a base? Why can't you see that? Why is it being mean today? Is that any better? Why didn't I put in a base right there? There's not a base here, right? So is that okay that I didn't put a base in my calculator? Yeah, what base is it? 10, right? We know that that's the common log. I don't know why it's not showing you the calculator today. It's being rude. Plus log of 9. Now when I graph that, I get that. Okay? So I have one side of the equation in F1, right? F1 is one side of the equation. What do I need to put in F2? The other side, right? So log of 54? Nope, not there. Oh, what did I do? Oh. Log of x, oh, look what I did. I accidentally put times log of 9 instead of plus log of 9. There, that's what I want. I don't know why it's not letting you see it today. It's being super ornery. Can you see that at all? So what we have to figure out is this blue one was the first one that we put in, right? Log of x plus log of 9. When is that greater than or equal to log of 54? Like if I graphed it, I'm gonna graph it a little bit exemplified or at least magnified so we can see it a little bit better. This is what the first one kind of looks like. And then this is what the second one kind of looks like. Right? When is this light purple one greater than the dark purple one? It's over here, right? In between these two sections right here. That's our shaded area. Okay? So we're just thinking with our brain, where is this one greater than this one? But that's what it's asking. Where is this one greater than this one, right? But it wants a solution. Now, we graphed it by graphing one side and then the other side, but really what we're trying to solve for is x, aren't we? We're trying to solve for x. So we only have x values that we care about. So if we go to our calculator, what if I found where those two crossed? What if I found where those two intersected? There we go, finally. Oh, it's because it went off. Okay, great. Menu, analyze, intersection. I want the intersection that's right here. Now I can't see it very well, so I'm going to grab it and pull it up a little bit. What do I care about in that point? The x. Okay, what is the x at that intersection point? 6, right? The intersection point right here is 6, 1.73. So all we're trying to solve for here is x's. So when is the x of this equation going to be true? On this side of that point, right? So whenever x is greater than or equal to 6. So if you're given a logarithmic inequality, graph one side in F1, graph the other side in F2, see where they cross, see where they intersect. Now you got to know where the shading was, and we just used our brain for that. We said, when is this one? Because we knew that was the one we put in first. When is that one greater than the other one? We did our shading, but we needed an intersection point where they crossed, where everything started. It's just the x value because that's the only variable that's in that problem. Does that help? Does that make sense at all? Okay.